day 2 of the special triangles and angles in standard position. Yesterday, you were given the angle and asked to find the ratio. So the questions were like sine of 4 pi by 3. And the questions today are sine theta equals, and you have to find theta. So you're finding the angle. And one of the things that people struggle with, I think more in grade 11 than in grade 12, but is the difference between those two questions. And it's easy to mix them up kind of thing or get confused about which is which. So keep that in mind that you definitely need to understand how to do both. And as I've always said, you don't want to be trying to figure it out during a quiz. You want to know how to solve them. You want to have experience and be familiar with it. You'll also notice that I keep asking you, it's on the learning goal, it was on the lesson yesterday, it'll be on the next learning goal, it's on the lesson today. Draw the triangle, label the triangle, and this is because you need to do it correctly when the quiz comes up. You need to make sure that you draw your triangle correct. So we're doing it over and over again. So you probably don't need my help by now. Go ahead and label the triangle. The equilateral triangle, the one on the left here, is the 60, 30, 90, but in radians, pi by 3 and pi by 6. And remember, those are the two that people mix up. The 6 is bigger than 3, so you put it in the bigger angle, but that's obviously not how it works. And it goes 1, 2, root 3. Okay, and the next one, again, your right angle. Isosceles, so both pi by 4, 45 degrees, and 1 root 2. And if you don't have that memorized, like go home tonight and draw it 100 times or something, right? Draw it, go do something for 5 minutes, draw them again, go do something for 10 minutes, draw them again, right? Have a break, or draw it 100 times in a row and take a break for half an hour and try to draw them again. Like, do something to make sure that you learn them. Okay, you're just memorizing them basically, and they're kind of crucial to everything, right? Everybody good? Okay, so let's try them. Oh, take a look at the instructions here. For each of the following, determine theta if it's between 0 and 2 pi. So these questions give you a domain, otherwise there would be infinite answers. And that domain can change. And the last example that we're going to do together today will explore that a little bit. In grade 11, I think sometimes they do 0 to 180, which for us would be 0 to pi. And I think in Unit 2, there's a couple of questions that do that, because we start to get questions in Unit 2 that have a lot of answers, like 8 answers. And so we shrink the domain just to have fewer answers. You probably have 4 in that case. So I think it occasionally in the second unit of trig, we might have a domain of 0 to pi. But 0 to 2 pi is the standard. Mostly that's what we're going to do, but like I said, we are going to explore one that's a little bit different at the end of this lesson. So you got to make sure that you know what domain you're working in, okay? And then it says exact value if possible, otherwise round to 4 decimal places. This is another key element to be aware of in this course, in both this unit and the next trig unit. That's always going to be the expectation, is that you know when you can get exact value or when you can't. On the quiz, it's exact value because you don't have your calculator. If it's not exact value, that means you have to use your calculator. You need to know when you can do each of those. You need to recognize that. Okay, so for the test, it's not going to tell you in the instructions, round these ones and these ones exact. It's going to say it exactly like this. If possible, leave it as exact value. If not possible, round to usually 4 decimal places, but whatever it is. Okay? So that's important for you to know that that's the expectation. Okay, so now if we're working backwards compared to what we were doing in the last lesson, and we're finding the angle, where do we start? What do you think? So what do you mean by that? Start with the triangle.
Before we draw draw the line on a graph, why don't we start with one of the special triangles?
But tell me a little bit more. You're right. I think that's a good idea. Can you tell me a little bit more, like how the triangle helps us, or what we do with the triangle? David?
With the ratio, you can find out what angle was referenced.
Okay, so when we're looking at that ratio, it's going to tell us which triangle we're in, right? So we're in the isosceles triangle with the pi by 4s, because that's the only, they both have a 1 in them, but this is the only one with a root 2. The other one has 1, 2, and root 3. So when you look at the ratio, you can tell which triangle it is, and which triangle it is gives us what? It's got a name. Theta related, the related angle, right? So and when you're in this triangle, folks, I mean, hint here, there's only one angle that it can be. It can't be pi by 2. It's never pi by 2 from the triangles. So theta related is pi by 4. And I said this in the last lesson. It's really important that you call that theta related. You can't call that theta. If you do that on an assessment, you lose marks. Okay, so when it's theta related, you have to call it theta related. When it's theta, you call it theta. They're very distinct. Again, I think often in grade 11, students kind of don't really get the difference between them, or don't really think it's that big of a deal. And maybe in grade 12, you're really starting to, but they are two totally different angles. Okay, now what do we do? Evan?
We find where it's negative.
We find where sine is negative. And why? Because, well, sine is negative, right? The ratio that we're given is negative. So we have to figure out what quadrant sine is negative. And how am I going to do that? Evan, do you know? Cast rule. Good. And sine is negative in the bottom two quadrants. So I need to find theta in quadrants 3 and 4 that has the related angle of pi by 4. So how do I do it for quadrant 3? Zach?
180 plus the theta related.
But not 180 if we're in radians, it's?
Oh, theta.
Nope.
I mean,
Yes, I know you mean it.
yeah.
Pi, yeah, good. Pi plus theta related, which is pi plus pi by 4. How am I going to add those together?
You turn the pi into a fraction, so it would be 4 pi over 4.
So all that work we did counting in fractions in the previous lesson, 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, I hope that you've been practicing that and doing that and getting more used to fractions. And this idea of pi being 4 pi by 4 is something that we should be at least somewhat familiar with from yesterday, because we were doing that to find the related angle. Because that's, exactly how you have to do it. You don't have to show all these steps, by the way, but I'm going to sort of take it a little bit slower to start to make sure everybody's on board. So 4 pi by 4 plus 1 pi by 4 is 5 pi by 4. And when I say that this is similar to what we were doing yesterday, what I mean is I've gone 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4, which is 1 pi by 4 more, to get to 5 pi by 4. And that is a quadrant 3 angle. 5 pi by 4 is just past 1 pi by 4, quadrant 3 angle. And if you were successful with learning that and understanding it yesterday, it's basically the same kind of thinking. Sort of backwards, but same idea. So hopefully that understanding from yesterday will transfer to also being able to do this fraction math. Okay, and then we also are in quadrant 4. So how do I get the result in quadrant 4?
2 pi minus pi by 4.
2 pi minus theta related, which is pi by 4, very good. 2 pi minus pi by 4. So what do I turn 2 pi into to actually do this subtraction?
8 pi by 4.
Very nice. So I just double the denominator of 4, because we need a common denominator. So 7 pi by 4. 8 minus 1 is 7, 7 pi by 4.
You have to show the
You do not have to show all those steps. For the quiz, I would like you to show a couple of steps. You could go straight to that. and then the result. Or some people might, I think a lot of people might want to start there. I certainly wouldn't be writing out the formula, but you can. Of course, you can always show extra steps if you're more comfortable. But you could go to there. But, because I want you to show some of your thinking and show some work, so I'd like to do that. But eventually, especially in the next unit, we will not be showing any of that. We'll be going straight to the answer. Because you're going to do so many of these, you're going to be that good that you're just going to be able to do it in your head. Okay? So I'm just going to summarize. Therefore, theta is equal to 5 pi by 4 and 7 pi by 4. Okay, ready to do another one? So remember I made the big deal in the last lesson about not flipping the angle when you have a reciprocal ratio. But this time we're given the ratio, so we are going to flip it. There are two ways you could do this. Just watch for a second. If tan of theta is opposite over adjacent from SOHCAHTOA, right, obviously, then cotan, it's the reciprocal, so it is adjacent over opposite. So I mean, you could kind of do it that way, but I think there's a safer way to do it. We're not really familiar with the reciprocal angles doing them like the SOHCAHTOA way. So cosecant, which is the reciprocal of sine, would be hypotenuse over opposite. That's just a little unfamiliar. So it's really easy to turn this into a more familiar question, and that's by you do flip the ratio. And now it's a tan question, which we're good at, and we'll just do it that way. Yep.
So why is it that we can flip it directly now?
Because it's not an angle. The ratio is the thing that you flip. Yesterday we were given the angle. It would have been like cotan of 4 pi by 3. That is not equal to tan of 3 over 4 pi, right? It's 1 over tan of 4 pi by 3. Okay, so now we'll do it the same way as the last one. We'll go to the triangle. Which triangle am I in? There's only one that has a root 3 in it, so it's that one. Which is the pi by 3, pi by 6, and 1, 2, root 3. Very good. So how'd you get that?
Because that's opposite over adjacent.
So if I need this to be opposite over adjacent, that means root 3 is opposite, and 1 is adjacent. And what is opposite of root 3? Pi by 3. And adjacent to pi by 3 is the 1. So theta related is pi by 3. Next step, cast rule to figure out what quadrants we're in. The ratio is positive, so we're in those two quadrants. So if theta related is pi by 3, what is theta in quadrant 1? Pi by 3. It's equal to the related angle, right? In quadrant 3, we already did, so the formula is pi plus theta related. So I need to turn the pi into 3 pi by 3. So I can add another pi by 3. Again, the 3 over the 3 gives us 1. And 3 pi by 3 plus 1 pi by 3 is 4 pi by 3, which again is just past 3 pi by 3. So it's in quadrant 3, which is what we're looking for. Questions? What do you think? We're going to do a few more. And then we're going to do a couple that are a tiny bit different. And then one that's quite different. But is everybody okay with that so far? Remember, if this seems like voodoo magic to you, like where are all these numbers coming from, then you gotta ask, right? Secant is the reciprocal of cosine. So this is cos theta equals 1 over root 2. Okay, I want you to try this one on your own. Get as far as you can. Just like the last two that we started with the triangle to figure out the related angle. Then we used the cast rule to figure out what quadrants we're in. And then we calculated the thetas. Okay, I think most people are done. We're almost done. So I can walk us through the solution, but you should have got pi by 4 and 7 pi by 4. How many people got that? Awesome. Ooh. So 1 over root 2. Again, the root 2 tells us we're in this triangle. That triangle only has one angle that it can be, so it's going to be the theta related is going to be pi by 4. Cast rule, it's positive. So I go to the two positive quadrants for cosine, which are 1 and 4. And just like we did before, I then find, the quadrant 1 angle, which is just equal to the related angle. So it's just pi by 4. And the fourth quadrant is 2 pi minus pi by 4. So that's 8 pi by 4 minus pi by 4 minus 1 pi by 4. So that's 7 pi by 4. And again, this is stuff that you have to be able to do on your own. Like you could do this work with your calculator, right? 2 minus 1 over 4. I would leave out the pi's. And it's going to give you 7 over 4. And then you write the pi back in, basically. But on the quiz, you won't have your calculator. So you got to be able to do that by hand. So you have to understand that step. Again, I think you can do this one on your own, so give it a try. Okay, how we do on that one? So root 3 over 2 is in that triangle, because it's got the root 3 in it and the 2. Sine is opposite over hypotenuse, so the hypotenuse is obviously 2. So opposite of the root 3 is the angle pi by 3. Pi by 3 opposite over hypotenuse. So our related angle should be pi by 3. And it is sine that's negative. So that's the bottom 2 quadrants again. So in quadrant 3, it's pi plus theta related. And in quadrant 4, it's 2 pi minus theta related. Those same little formulas that we've been using all along. So 3 pi by 3 plus 1 pi by 3 is 4 pi by 3. 6 pi by 3 minus 1 pi by 3 is 5 pi by 3. And we've got those two solutions. Any questions? Okay, one more. This one's a bit different. -1 is not in the triangles. People might think it's this. 1 and 1. And it's like negative sine. But sine is opposite over hypotenuse. So the hypotenuse is always root 2. How could sine be 1 over 1? Okay, it can't. Tangent can be, but not sine. So this is a question where we sketch a little graph, right? And in the next lesson, we're going to be exploring the graphs a lot further with transformations. We're not going to be graphing, but we're going to be doing other stuff with it. So you'll start to get even more used to the graphs of sine and cosine, which will make this process easier. So that's sine. And remember, it's got 5 points: 0, pi by 2, pi, 3 pi by 2, and 2 pi. And it's at -1 there, which is 3 pi by 2. So there's no related angle or anything here. The answer is just 3 pi by 2. Any questions? Mm-hmm.
So here it's a graph and we only have one value for theta. How come we can have two values normally?
Well, when it's on the axis and I have pi by 3 as a related angle there and pi by 3 as a related angle there, and that's where sine is both negative. So there's two triangles that you can draw that give us that, right? Remember, I'm either spinning around to there. Whoops, sorry, that's not right. Spinning around to here or to there. Both those angles, which would be the 4 pi by 3 and 5 pi by 3 that we just did in the last question, right? Both those actual angles make a triangle with a pi by 3 in them, with the x-axis. Hold on, and that's where sine is negative. So you would have those two. 3 pi by 2 is on the axis. So it's on the axis. There's not two triangles. I mean, there is no triangles, really. That's why we don't use the triangles. But you could kind of think of like that's where the two triangles meet, right? So there's only one answer. The other reason is, where is sine equal to -√3 over 2? Well, there's two places the graph cuts it, right? Whereas between 0 and 2 pi, there's only one place that touches -1. So it's partly also because of that. A parabola has one vertex, but every other value it'll have two of, right? Any other questions? Okay, moving on to F and G. These ones are tricky. They're supposed to be easy, but they trick people because we do so much of the other stuff of the exact value, angles, and standard position that you're going to get so good at it and so used to it. And by the time the test comes around, you will have forgotten about these, unfortunately. And there'll be one on the test and people leave it blank and they're like, oh, I don't know how to do that. And it's like, yes, you do. First of all, we did them together in class and there's a whole bunch of them in the practice and there'll be some on the review. So you've done them a bunch of times, but you just don't realize that this is just a calculator question. So obviously this isn't going to be on the no calculator quiz. Is that what you were going to ask? But it will be on the test. But this is just a calculator question. Okay? So you just have to recognize it as such. And to get theta related, and again, you have to call it theta related. You do sine -1 on your calculator. And to do that, on my calculator, I hit shift, and I think you all know this, but I'm going to write it out once. Sine, that gets the sine -1, and then put in the number, and then hit equals. But you got to know how to do it on your calculator. Sometimes it says shift, sometimes it says second function. I hope everybody knows that's the same thing. Shift, sine 0.4567. And you should get that. And if you don't, maybe you're not in radian mode. And I'm going to round that to 4 decimal places. When it says in the instructions round to 4 decimal places, it also does mean like theta related, although there's a little trick to this. Your final answers have to be correct to 4 decimal places. So you've got a couple of options. What you don't want to do is round this and be typing it into your calculator for the next couple of steps. Because then your answer might be slightly off and you will lose marks if your answer isn't perfect to 4 decimal places. So I'm going to give you 2 options. And one is just learning how to use your calculator properly so you're not rounding. And the other option would be to write more digits, like keep a couple more digits, and then you could just type that into your calculator and it will give you the right answer to 4 decimal places. Okay? So let's see what I mean. What's the next step for this? Like this is not a triangle. No, we didn't talk about triangles because this value isn't in the triangles, right? So we're using the calculator to get theta related instead of the triangle. But what do we do next?
We just figure out what quadrant it's in.
Right. So we're still using the cast rule. And the sine theta is positive. So that's in the top 2 quadrants this time. So theta in quadrant 1 is just equal to theta related, same as always. So it's 0.4743. And what's the formula for theta in quadrant 2? I don't think we've done that yet today.
180 minus, or pi minus.
Good. Pi minus theta related. And maybe it's a little less familiar, a little less comfortable because theta related is not like pi by 3, so you're not going to 3 pi by 3 and going back 1 pi by 3 to 2 pi by 3, and you're kind of not getting it. But it's the same formula, so it's still pi minus theta related, which is pi minus 0.4743. But again, I'm not punching that number into my calculator. Watch what I'm going to do. Most of you probably know this, but there's always 1 or 2 people that have never had a reason to use it or don't know about it or whatever. See this button down here? That's ANS. That's short for answer. So it will put into the calculator the last answer that your calculator did. And everybody, I hope, should have a calculator that can do this. So I'm going to do pi minus answer. So I'm not using the rounded answer that I wrote down. .6673. Now in this case, if I did use the answer, shift pi minus 0.4743. Now this says 6672, The answer is 6673, but it would be rounded up to 3, so it would be the same, so you would get away with it, but once in a while that would be wrong. And this answer would have a 2 there or a 4 there or something instead. And if you do that, you lose marks. So your answer does have to be rounded perfectly to 4 decimal places. I hope you understand what I'm saying.
Is it always going to be 4 digits after the decimal?
You go by what the instructions say. Generally speaking, as a standard in trig, that's what we asked for is 4 decimal places. The instructions say to round to 4 decimal places if you have to. But if for some reason the test said 3 or 4 or 5 or 6 or whatever, then you just do what the test says. Okay, yep.
Should we write radians after?
You don't have to. When we're converting back and forth, it's a good idea to say what unit you're working in, either with the degree symbol or RAD. But for this stuff, no, we don't list units. We just assume everything's in radians.
So to start, I did it in degrees, and I got 27, and then I'm trying to convert it.
Yeah, your number is going to be a little bit off because when you round to 27, if you actually use that rounded answer, that's rounding it a fair bit.
Yeah.
So don't do it in degrees. I don't want to see any degrees on your test either, right? So don't do it in degrees and convert. You got to do it in radians. So make sure your calculator's in radians.
Could we see the sign inputs with like with the D, G, and R above the ampersand, like instead of going into radian that function?
Say that again.
So you know how you can.
So punch it in degrees and then use the little button that converts it to radians.
Or how does that work when you like? I don't think it works if you have a degree and then.
Yeah, I don't know. I'm just going to say don't do it that way. Put your calculator in radians. Like that's how we do it. Our calculator is in radians and we do it that way. I wouldn't try to come up with another way. I have almost never used that button, so I'm not familiar with exactly how it works. It might be that you could somehow do it that way, like do it that way and have your calculator convert it for you. That might work. I don't know for sure. Okay. Okay. Next one. Secant is the reciprocal of cosine again, right? We did that before. So cos theta is equal to negative 1 over 4.3838. So theta related. Remember, you don't put the negative into your calculator. The reason is you don't understand what your calculator does when you put a negative in. You could figure it out. But the safer way is not including the negative, because then you get theta related, and then you know what to do with theta related and the negative, because that's all the work that we've been doing. So rather than trying to figure out, like, watch what's going to happen. Cos of negative 1 divided by 4.3838. So I got 0. Is that right that I typed it in? Yep. 0.97. And then if I do cos of 1 divided by 4.3838, which is the one that we actually want, oh, it's the same. Which in some cases it's going to be. That actually makes sense. If I did this with sine, it would not be the same. So this is what I'm trying to say. Like if you don't know what it's doing, so don't do that. Okay. If you're curious, you can figure it out, or you can ask me and we can talk about it. But generally speaking, we do cos negative 1 of 1 over 4.3838. And this is something that we could make more sense of exactly what's happening in the next trig unit when we talk about some different things. So notice this is not negative. Yes? Question?
Just on your calculator thing over there, that's cos of that of 1 over.
Shift cos, thanks. That's why it was giving me the wrong thing. I knew something was wrong with it. Shift cos of 1 divided by 4.3838. They shouldn't be the same, and they're not. Okay, so take a look at that. Thank you for mentioning that because I would have had everything wrong. So this is the right one where I didn't include the negative. So theta, whoops, theta related. You obviously don't have to write that step. $1.3407. Make sure you can get these numbers on your calculator too, right? Like you should be doing this along with me. Cosine is negative there and there. So theta in quadrant 2 is pi minus theta related. And theta in quadrant 3 is pi plus theta related. Now I'm going to show you a little trick here. This is a minor detail, but some of you it'll click for you, and you may think of it yourself. I don't know. Again, when you need to get exact value to 4 decimal places, I would do these backwards. I'm going to do this one first. So put your pencil down and just watch for a second, and I'll show you why I would do this in this order. So I'm going to take this number and just go plus pi. Pi plus a number and a number plus pi is the same thing, right? So that's going to be this one. And then I'm going to subtract pi to get back to that, so that I've got that stored in my calculator again. And then go shift pi minus that answer, which is the 1.8009. Therefore, theta equals 1.8009 and 4.4823. If you didn't do it that way, if you don't like that for whatever reason, you could do it this way. So I've got that theta related on my calculator. I just hit equals again. And I would go shift pi minus answer to get the first one. And then you either type it back in again, shift cos of such and such, or you go up and hit equals again. So you've got the answer stored again. And then shift pi plus answer. Like, however you want to do it on your calculator, you figure out a way that works for you, that's fine. The first way I showed you is a little bit more efficient. Not saving you that much time on a test, but, you know, understanding sort of how to effectively or efficiently use your calculator is a useful tool. Any questions? That's it for the questions with the standard domain. Now we're going to do a couple in a different domain. Some people find these very tricky. I remember in the past I've had some people ask 5 or 6 times over and over and over again, can you explain it again? Can you explain it again? Like they come back the next day and the next day. So listen, this is not a big part of any of the assessments. Yes, it'll be on the quiz. Yes, it'll probably be on the test. But it's like one question. So you need to get good at all this other stuff. This is your main focus. Okay? This is like a level 4 extension kind of question. Like if you're awesome at those other ones, then try these. Don't obsess over these right now. Okay? If you've got that written down, I want you to put your pencil down and just watch for a second. Number line. When you first started learning about numbers, these are the numbers you learned about. Positive integers, or the whole numbers, they're called, right? And then eventually learned about decimals and fractions and stuff like that. And then eventually you learn about integers. And what do you learn about integers? Well, they're just going the other direction on the number line. And maybe your teacher talked about like negative temperatures, or debt of money or something like that to try to explain what a negative is. And it's hard at first, but now you're all fine with negatives, right? So if positive integers go that direction or positive numbers go that direction, negative numbers go that direction, right? And we're all familiar with that? So if positive angles go that way, what's a negative angle?
Do they just go the other way?
It just goes the other way. And this becomes all about the quadrants. You have to force yourself to think about which way you're rotating to get to a quadrant. So if this is my domain, I'm only allowed to go there or there. So I still have all four quadrants. But if I want to get to quadrant 3, for example, because tan is positive there, I have to go this direction. So I have to use a negative angle to get that way. And I have a little demo that might help. To get, if I go positive 2 pi by 3, I get to quadrant 2. And the related angle is pi by 3. If I go negative 2 pi by 3, so 2 pi by 3 is a quadrant 2 angle, but I've gone negative 2 pi by 3, so I've gone 2 quadrants in the other direction, but we still call that quadrant 3. So I've traveled through 2 quadrants, but I've landed in quad 3 because I went the other direction, because 2 pi by 3 is still going to take you 2 quadrants, but it's negative 2 pi by 3. So the related angle is still going to be pi by 3, but if the angle is negative 2 pi by 3, I'm in quadrant 3. So this is what I mean when I say everything comes down to what quadrant you're in. And most of the work for these is going to be exactly the same. It's only the last little bit at the end that's a little bit different and is a little bit tricky. But you know, you could try drawing it and drawing an arrow going one way and drawing an arrow going the other way, like I did, right? Okay, now let's try a couple. First step is the same. We're going to the triangle, to figure out what triangle we're in, to figure out our related angle. We already did this question, by the way. We already did one exactly the same, sine theta equals negative root 3 over 2, but it was for the other domain, right? So if this feels familiar, then that's probably why. So opposite over hypotenuse means theta related is pi by 3. So again, that's all the same, right? That's not different. Then we go to cast rule. And it's sine and it's negative. So sine is negative in the bottom 2 quadrants. This is where the negative angles come into play. If it was 0 to 2 pi, I would get to quadrants 3 and 4 by going around. And like we did in the last question, I would have got to 4 pi by 3 and 5 pi by 3 to get to them. But 4 pi by 3 is bigger than pi. It's not in this domain. So that's not how we do it. We have to go back this direction to get there, and back this direction to get there. So what is this angle? Just visualizing it. I'm going to show you a little bit of how to calculate it with a like a formula, but just what is it by looking at it?
Is it pi by 3?
But it's not pi by 3, it's
Negative pi by 3?
negative pi by 3, right? Because that's telling us the direction. But you're correct in your thinking that that's the distance that you've traveled is theta related, because you're going into the first quadrant that happens going that direction. So it's as if you're calculating a first quadrant angle. So theta in quadrant 4 is equal to negative theta related. You can just put a negative out in front of each formula, and that will calculate it for us if you like to do it that way, or you can just visualize it. So what about in quadrant 2? Sorry, not quadrant 2, in quadrant 3, the second quadrant.
Would it be pi minus pi by 3?
Yes, close. Yeah, okay, so it would be negative pi minus pi by 3, because this is the quadrant. Sorry, I'm going to put theta related. Because that's the quadrant 2 formula, and I've traveled 2 quadrants, but I've gone the other direction to go to quadrant 3, so I put a negative out in front of it. Does that make sense? But folks, you might also just go 1 pi by 3, 2 pi by 3. So I've gone 2 pi by 3s to the negative, which is going to be negative 2 pi by 3. So this equals negative 3 pi by 3 minus 1 pi by 3, which is 2 pi by 3, so negative 2 pi by 3. What do you think? I hope you see what I mean when I say it all comes down to which quadrant you rotate into. And thinking about that you've rotated in the negative direction, how many quadrants did you travel through? And, thinking through it like that. We're going to do a couple more together. And don't forget, this is the hard stuff. So make sure you get the easier stuff first. We haven't done too many with tan. If this were sine or cos and there was a 1, then it would be a graph question, but that's not the same for tan. So this is a triangle question. Because tan is opposite over adjacent, so the 1, 1 root 2 triangle has 1 over 1. So theta related is pi by 4. Cast. Again, this is all the same as what we were doing before. So you can do all of this part. It's positive 1. Tan is positive, and 1 and 3. To get to quadrant 1, it's the same as we've always been doing because I'm still rotating in that same direction. So it's just pi by 4. There's pi by 4 in quadrant 3. If this was the regular, don't just watch for a minute. If this was the regular, you'd be going 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4. And this is what I mean by instead of those formulas, maybe you just do this. 1 pi by 4, 2 pi by 4, 3 pi by 4. So I've gone 3 pi by 4 that direction. Which is negative. And instead of using those little formulas, just think about it. We got one more, and it's a little bit different. Cos of 0. So this is a graph question. How would we do a graph question this is not something that's going to be a big part, but when we get into graphing and when we get into some stuff in the next unit, it will become important that you're starting to think about this stuff. Okay? So this isn't crucial right now, but it's coming, so it's good to talk about things ahead of time so you can think about it for a bit, and then when you see it again later, you'll be like, oh yeah, I kind of remember talking about that, now it makes more sense. So cosine does this. And our domain is negative pi to pi still. So this is where pi occurs. So where's negative pi?
Just like look on the other side of the graph.
Yeah, we just keep drawing it. Whoops, that wasn't very symmetrical. It's better. And negative pi would be there. Remember, we are used to only thinking about one cycle of these functions, but they go on forever. We only draw one cycle typically, but that they do keep going. So we could just keep drawing cosine over and over and over again and over, right? So this is our domain. So where is cosine equal to 0? Right here and right here. And what are those two values?
Negative pi over 2 and pi over 2.
Good. Negative pi over 2 and pi over 2. And you just have to know that because you have to know that about the graphs. The question on the quiz will be a triangle question, not a graph question when it's the negative pi to pi. But like I said, that's something that's coming up. And we're going to talk about the graphs more and more and more starting in the next lesson. So if you're a little hesitant or unfamiliar with the graphs, probably that's going to help a lot. Yes?
The 2 points after aren't. Oh no, wait, I get it. 'Cause
These
they're
ones
pi.
are.
They're 0, 2, but then we're doing negative pi.
Right, but that's good. Those are equal to 0 as well, but they're outside the domain, so we don't include them in our solution. But what if we increased our domain from negative 2 pi to positive 2 pi? Then they would be in there, right? You'd have 4 solutions. So anything can happen. So that's a good question. Any other questions? Yes?
So the 0 is the y value?
Yeah. Yeah.
And then how does that look? So we usually have a linear relation, we don't have the x and the y. What is the cosine?
This is the graph of y equals cos of x. Right? So 0 is like the y because it's equals 0 and it's equals y. And the theta is like the x. So the theta is the x value of pi by 2, the horizontal value. But the 0 is the y value. So where is y equal to 0?